Hello everyone and welcome back to my channel Learn with Lakshay Tanwar. If you're new to my channel, please do subscribe, like and share my videos and drop your doubts in the comment box. So this is part 2 of introductory video class 9 mathematics chapter 1. If you're new to my channel, you can visit my channel and see the first part. So let's get started. We will be discussing two different topics, only two topics in this part. First is your decimal expansions and the second one is going to be your history. Okay, so we'll discuss that afterwards. So real numbers and their decimal expansions. What do you mean by decimal expansions? Decimals we all have studied many a times. In 8th we studied decimals. This is my decimal, right? So decimal expansion is what? Decimal expansion is when I expand my numbers into different decimal places, my rational numbers and my irrational numbers. So first we'll read what's written on the screen and then we'll continue. So the decimal expansion of a rational number is either terminating or non-terminating recurring. Recurring basically means repeating. Writing it on the screen for your ease. So recurring basically means repeating. Moreover, a number whose decimal expansion is terminating or non-terminating recurring is an irrational number. This is very, very important. The decimal expansion of an irrational number is non-terminating, non-recurring. Moreover, a number whose decimal expansion is non-terminating, non-recurring is irrational. Now, when I speak, it seems to be a little confusing, but it is not. Actually, it is very, very easy. So we'll understand there are three different types of decimal expansions. We'll talk about each one of them. So the first one is terminating decimal expansion. First one is terminating decimal expansion. The second one is non-terminating but recurring. It's not terminating, but the digit is repeating again. So it is known as non-terminating recurring. And the last one is non-terminating. This is NT and NR. That means non-terminating and non-recurring. We'll understand each of them. So terminating is like when I say divide 2 by 2. So I get my remainder 0 because 2 into 1 gives me 2. When I say divide 10 by 2, then also it is my terminating decimal expansion because 2 into 5 gives me 10. So I get my remainder again as a 0. So when the remainder after division comes out to be 0, then the decimal expansion of a particular fraction is known to be terminating. Simple. Non-terminating repeating is when there is no 0 in the remainder. You keep on dividing, but the 0 in the remainder never comes. You will see कि 0 kabhi aa hi nahi raha hai. There will be no 0 coming in the remainder. But some of its digits, either its last digit or the whole digit, all the digits that are present after the decimal are repeating again and again and again. Okay, and the third and the last case is that neither it is terminating nor it is repeating. Different types of digits are coming into different orders at different times. There is no repeating of digit or no repeating of digit order. Alright, there is no repeating, so then it is non-terminating, non-repeating. When a decimal expansion of any given number is terminating or non-terminating recurring, then it is said to be a rational number. Like let's for an example, there is a number, there are two numbers, one of whose whose the decimal expansion is terminating and one of whose decimal expansion is non-terminating recurring. Then both of those numbers will be rational numbers because we know rational numbers are the numbers which have such type of decimal expansions. But if the decimal expansion of a given number is non-terminating, non-recurring, that is neither you're getting a 0 in the remainder nor there is any repetition of the digits, then it is an irrational number. Make it a very important point because there are very important questions related to this topic and we are going to discuss this with the help of some examples over here. So the first one is divide 10 by 3. So we'll divide 10 by 3 and we'll see what kind of decimal expansion it has and we will be able to tell whether it is a rational number or an irrational number. Alright, so we'll divide 10 by 3 like this. In quotient, I'll get 3 because 3 into 3 gives me 9. 3 times 3 is 9. When I subtract, I'll get a 1. Now remainder. Now this much is clear that it is non-terminating for the time right now. If after putting point also, if I'm getting a 0 in the remainder, then also it doesn't matter. Then also it will be terminating decimal expansion. You will see that in further examples. Alright, so now I'll put a point over here. Since I put a decimal, so I can get it again 0. Now this is very, very common. If I'm getting the same digit back again, I'll use the same quotient, which is 3. Again, I'll write 9 over here. 10 minus 9 again gives me 1 over here. So again, the same scenario will keep on going and going and going. So after the decimal place, the only digit that I get is 3 and is the only digit that is going to keep on repeating. So it is a non-terminating repeating decimal expansion. Neither it is not terminating, the remainder will never be 0, but 3 will constantly repeat. So it is a rational number. Since its decimal expansion is non-terminating repeating, therefore it is a rational number. Next is 7 divided by 8. Now this division is quite long, so we'll rub this up and we'll start it again. So this is 7 upon 8, right? Let's start. So I will be dividing 7 from 8. So first of all, 7 can't be divided by 8, so I'll again put a 0 in the starting itself and I'll put a point over here. So this becomes 0. 8 times 9 gives me 72, that's bigger, so I can't use that. So 8 into 8 gives me 64, so I'll do 8 times 8 gives me 64. As simple as that. Now 70 minus 64 gives me what? That's 6. Very simple for us. Right? We are so intelligent. So this is 60. 8 into what gives me 60? 8 into 7 is 56. So I can directly use that. 60 minus 56 gives me what? 4 again. Now since this is a decimal place going on, so we'll put a 0 back again over here, and this becomes 8 into 5 gives me 40. So my remainder becomes 0. So this is what kind of decimal expansion? This is a terminating decimal expansion. In the last division, that was 10 divided by 3. When I had put the point and I said that now this is clear that since we are putting a point and there is no 0, so it means it is not terminating, but that doesn't matter. If you put a point and after that also you can get a 0 in the remainder, then also it will be a terminating decimal expansion, like in the case of 7 by 8. Simple. So 7 upon 8 will be 0.875, so this will be a terminating decimal expansion. So again, since the decimal expansion is terminating, therefore it will be a rational number. Very simple. Now we'll start with the third and the last part, which is 1 divided by 7. So 7 से हम 1 को divide करेंगे. This is going to be a quite long one. So I'll put a 0 in the beginning itself because I know that 1 can't be divided by 7. So 7 into 1 gives me 7. Now 10 minus 7 gives me 3. We'll put a 0 again. 7 into 4 gives me 28. 30 minus 28 gives me 2. Again I come up with a 0. 7 into 2 gives me 14. 20 minus 14 gives me 6. Again I'll put a 0 and I'll continue with that. So 7 into 8 gives me 56. So I'll use that particular multiple. So 7 into 8 gives me 56. 60 minus 56 is again 4. I'll use this 0 over here. 7 into 5 is 35. So 40 minus 35 gives me 5. Again I'll put a 0 over here. Now 7 into 7 is 49. So I'll be left with a 1 in my denominator. Now you see very carefully. I started with a 1 and I came back to 1. That means 142857. The whole quotient is going to repeat again and again and again. So this is again non-terminating but repeating decimal expansion. If it is non-terminating but repeating, then what kind of number is it is supposed to be? It is supposed to be a rational number again. Very simple. Next, we'll start with the next topic, which is operations on real numbers. Operations may again, from nursery itself, we are talking about 4 operations: addition, subtraction, multiplication, and division. And the same 4 operations we'll be talking about on the real numbers as well. So the first one is addition, the most friendliest one to us, because when we add 2 expressions, we don't have to change the signs. But when we subtract 2 expressions, we have to change the signs by putting it inside a bracket, and that becomes a little confusing for some of the kids. So for this part, I don't need to put a bracket in this thing. So this becomes directly 2 root 2. Now I'll find this common. This 2 root 2 and root 2 have root 2 in common. Now root 2 has nothing in front of it. That means it is 1. And since it is addition, so I'll do 2 plus 1 gives me 3. So this becomes 3 root 2 plus. Now the other thing is 5 root 3. Now this is a plus. Okay, LCM wala table nahi hai. Don't get confused. This is plus. 5 root 3 minus 3 root 3. Again, yahan pe since we are not changing the signs because it is your addition, so therefore this will be 5 minus 3 because root 3 again we have in common. So 5 minus 3 gives me 2 root 3. This was quite simple. Now I can't solve it further because we have nothing in common. Is it so? No. If I write wrong answer, then we can. Because over here I wrote 2. If it was so, this would have become 3 plus 2 gives me 5 root 2. But it is actually 3 over here because root 3 was gone. So this is 3 root 2 plus 2 root 3. But if it would have been 3 root 2 plus 2 root 2, then it would have become 5 root 2. Simple. Next example is multiply 6 root 5 by 2 root 5. So 6 into 2 gives me 12 and root 5 into root 5 gives me, see, when I do root 5 into root 5, it becomes root 5 plus square. Square and root cancel each other, so this becomes 5. So 12 into 5 gives me 60. Very simple. This is also done. Multiplication was quite friendly to us in this part, but not any more in the exercises when you do that. Okay. Then next we have a division wala thing, so we'll do this as well. We have divide 8 root 15 by 2 root 3. Very simple. Now we know cubes and squares. We all know. So 8 is 2 cube. 2 into 2 into 2 gives me 8. So therefore this is very simple. 2 and 8 can cancel each other. So this becomes 2 into 4, which is 2 square. And root 3 into root 15 have something in common, guys. Please see it very carefully, because when I say root 3, it is root 3 into 1, which is root 3. And when I say it is root 15, then I can break it down into simpler roots, which is root 3 into root 5. 3 into 5 gives me 15. Similarly, root 3 times root 5 gives me root 15. Because 3 times 15 gives me 3 times this thing 5 gives me 15. Therefore, root 3 times root 5 gives me 15. This is a simple logic with which you can understand it. Okay, so root 5 can be broken down into root 3 into root 5. Now, root 3 is in the denominator as well and in the numerator as well. So, root 3 and root 3 gets cancelled. 4 के साथ में क्या बच जाएगा? Only root 5. So, our answer would be 4 root 5. This was also very simple. So this was the end of our second part. If you have any doubts in this part, please drop your doubts in the comment box, or any other doubts which you have related to maths and science from class 6 to 10. Till then, bye bye.